Hi there, this is Architect David. Welcome to Arkida, where you can learn anything and everything about construction. For this video, we will be talking about the basics of structural steel framing. The first is the rigid steel frame, also known as a shear frame system. Beams and columns are rigidly connected. Bay dimensions ranges from 6 meters to 9 meters. The advantage for this is it is uncluttered and rectilinear. The disadvantage, it has too many joints and too many steel requirements.
An example of a rigid steel frame is the home insurance building done in 1884.
The next type is the braced rigid frame. It is also known as a shear truss and frame system. Shear trusses in the vertical direction combined with perimeter shear frame. It is applicable to 10 to 40 stories. Some cases, braces are applied in both directions. It is called truss bracing, which is the K form or the X form or a single brace form. The advantage of this is the most economical steel structural system for buildings up to 30 stories high.
For the braced rigid frame, look at the Empire State Building, which was done in 1931.
The next type is the outrigger and belt trusses. Now, to tie the exterior fascia shear frames and vertical trusses, outrigger and belt trusses can be used. It is placed usually at plant room levels or the levels where there is a mechanical room. Advantage is that it enhances participation of exterior frames and reduces building sway under wind.
For the outrigger and belt trusses, look at the Petronas Twin Towers done in 1998.
The next type is called as the braced tube, which is also known as diagonalized tube. It has fascia diagonals. The advantage for this is it eliminates closely spaced columns of frame tube, suitable for multifunction use since interior now is free from structure for resisting wind action.
For the braced tube, check out John Hancock Center in Chicago done in 1970.
The next example is the frame tube system. Frame tube system is one of the most widely used tube systems compared to tube-in-tube system. It features a much stiffer exterior tube in this type of system. The stiff tube was achieved through closely spaced columns connected by deep spandrel beams, which are firmly joined together to make the stiff exterior shell. Depending on the structure, the spacing of the column is quite close, generally 1.5 to 4.5 meters spacing, while spandrel beam depths can range from 0.5 to 1.2 meters.
One perfect example of the frame tube is the former World Trade Center in New York.
Now, this is a comparative analysis of the four types of framing systems that I've just discussed. The orange square here is the efficient height of a building based on the framing system. It will say efficient because that is the most advisable height for that type of structural system. The next system is called the bundled tube or modular tubular system. The columns are spaced at 4.6 meters, form the walls of the tube, and deep frame beams at each floor. It creates a vertical modulation in a logical fashion. Variety of floor sizes becomes an asset for real estate marketing. It is applicable for 30-story to ultra-tall structures. Each beam can be arranged in a variety of ways to create different massing.
For the bundled tube, check out the Sears Tower or the Willis Tower in Chicago, which is 110 stories.
The next is the core and outrigger. If you'll notice on the picture, it shows a Philippine bangka or canoe, wherein that extended part, which is highlighted in the red square, is the outrigger itself. It keeps the bangka or the canoe upright. So the outrigger serves to reduce the overturning moment in the core that would otherwise act as a pure cantilever. and to transfer the reduced moments to columns outside the core by way of tension compression coupled, which takes advantage of the increased moment arm between these columns. It also serves to reduce the critical connection where the mast is steep to the keel beam.
For the core and outrigger, check out Taipei 101 done in 2011.
The next is the Diagrid framing system. It's designed for constructing large buildings with steel that creates triangular structures with diagonal support beams. It obviates the need for large corner columns and provides better distribution of load. Its efficient height is roughly 100 stories.
For the Diagrid framing system, check out Hearst Tower by Foster & Partner, done in 2006.
As for the picture here, the Diagrid framing system shows a sturdy central core surrounded by 3 building wings. The wings are codependent and each is supported or buttressed by the other 2. Tapering is necessary as the building rises to minimize wind effects.
For a Diagrid with 3 building wings, check out the Burj Khalifa, done in 2010.
Now here is a comparative height analysis of the 4 recent types of structural framing that I've discussed, which shows the Willis Tower, Taipei 101, the Hearst Tower, and Burj Khalifa. We now move on to mixed steel-concrete systems, wherein the first variation is called the composite tube system. The structural concept is based on a tube-in-tube concept, wherein the exterior is reinforced concrete frame tube, while the interior is a shear wall core tube. The example for this is the picture here, which is the first Canadian center in Calgary, Canada. Next is the core braced systems, wherein it would resist wind forces by shear walls in the core, and steel components need only be connected non-rigidly to resist gravity. Then, what we have here is called the super truss tubes. Horizontal and vertical facets of the shape are modularized so that the triangular shaped framing can be used without discontinuities. The internal structure is supported on 3-story tension truss elements span across the tube, and there are no internal columns. The last variation is called the exoskeleton. It is defined as the external skeleton that supports and protects an animal's body. So, in architecture and construction engineering, the building technique is called monocoque. Monocoque is the structural approach that supports loads through and the object's external skin.
For the exoskeleton, check out 014 Tower by Reiser and Umemoto.
Well, I hope you've learned something new today. Watch out for my next videos. If you like it, just press the like button, press subscribe to be able to access more of the videos of this site, and press the notification bell to be informed of new videos that come out. Click the subscribe button to discover all the other videos in this site. Click the notification bell to be notified about new videos that we post. Press the like button to share this video to your friends. If you have additional comments, please post them down below or at our Arkida Facebook page, and I will answer all your queries. Thank you.